Hey guys, how's it going? So today I want to go through section 5, which is solving inequalities where you have x's on both sides. So for the most part, it's going to be the same as solving equations with x's on both sides, which we did last chapter. The single most important thing that I need you to remember as we're working on this is, and this is going to be true the whole, no matter what we're working on, is if you ever multiply or divide by a negative number, you have to remember to change or flip the sign, okay? But that's the only time you'll ever do that, okay? So when you solve these, just like solving these when you had an equal sign there, the first goal was you want to get all the x's or variables on one side, okay? So just like before, we want to get all the x's on one side. Now, it doesn't really matter which way you go here. Most people like to go to the left. But if you go to the left in this case, you are going to end up negative, okay? So that actually is probably the best thing to do with these. That's the one main difference, okay? So I would say we would minus 7x, okay? Now, when we minus 7x there, we do end up with a negative 3x over here, right? Over here we have our 6. We would not flip the sign here because we're not multiplying or dividing, we're subtracting. Now the next step, how do you get rid of the negative 3? We would divide by negative 3. Okay, now because we're dividing by negative 3, we have to remember to flip that sign over, right? So we would have x over here. 6 divided by negative 3 is negative 2. Okay, now if we would have done that same problem when we had 4x is greater than or equal to 7x plus 6, if we would have done the trick we did last time where we tried to stay positive, we can do that. Negative, if you minus the 4x, over here we'd end up with 0. We would not flip the sign over because we're just minusing 4x. So we'd have 3x plus 6, right? We would minus the 6 from both sides. Again, we would not flip the sign over. 0 minus 6 would be negative 6. We'd have 3x over here. And then we would divide by 3. Now, again, not going to flip the sign over, right? We'd have x and we'd have negative 2. Now, notice this is backwards, right? The inequalities are a little harder to understand where this says negative 2 is greater than or equal to x. This says x is less than or equal to 2. If you flip this over, put the x on this side and the negative 2, just remember you got to flip that sign if you do flip the equation. So yes, those are the same thing, okay? So it really doesn't matter which way you do things. I, with these, kind of tend to go with not necessarily trying to avoid negatives, but just trying to get the x's on the left. It usually makes things a little bit easier for people. So I would do the same thing here. I want to get all the t's on one side, so I would want to move to the left. So I would add the 2 t's. So I'd have 7t plus 1 is less than, not going to flip the sign, so we're just adding 2t. Those cancel, negative 6. Then we would minus the 1, right? So I have 7t, not going to flip that sign over, negative 7. And the last step is to just divide by 7. Now again, we're not dividing by a negative, even though this 7 is negative. The number we're dividing both sides by, this 7, is positive. So we would not flip that sign over. We would just get negative 1. Okay? Now, we are going to run into some story problems from time to time with these. And the first thing you'd want to do is set up your inequality. So this one says an advertising company charges a fee of $24 plus 10 cents per flyer to print. All right, print and deliver. So we got $24 plus 10 cents, 0.1, per flyer. We'll just put an x, right? We have to multiply that by x. Now a different company, a printing company, charges just 25 cents per flyer. So another company is just 0.25 x, right? This is the advertising. This is the printing, right? Now, the question is, for how many flyers, how many x, is the advertising company less than the cost of the printing? So we want to know, when is this less than that? And then we just got x's on both sides, so we'd want to solve this. Now, if you want to, yes, you can. I know that I just said before, we like to move to the left. If you want to, you can move to the right, right? Just for know, if you do that, you're going to have to flip it at the end. Okay, so those go away. We got 24 is less than 25 cents minus 10 cents would be 15 cents. And then I'd have to grab a calculator and divide by 0.15. So I'd have to do 24 divided by 0.15. That comes out to 160. So when we divide by that 0.15 on both sides, we got x was greater than, reading it right to left, that was 160. Now, that is a correct answer, but it's a lot better if we flip that around, put the x on the left side and the 160. But if you do flip an inequality, you do have to remember to flip that sign. Okay, so basically, that means the advertising company is cheaper if we are greater than 160. If it's less than 160, the printing company would be cheaper. Okay? All right, so let's try. Now, there's a couple, just like when we ran into inequalities or equations with x's on both sides, sometimes you're going to run into some interesting ones where all the x's go away. So if you had something like this where it said 4 plus x is less than 10 plus x, and you minus x from both sides, we end up where all the x's go away. Remember before, we had, if it was a true statement, that was all real numbers. Well, now it's a little easier to get a true statement. Okay? Yes, 4 is less than 10. So that's a true statement. If that's always true, or it just comes out to be a true statement, the answer is that's all real numbers. We call that an identity. When the same thing happens, we have 4 plus x is now greater than 10 plus x. We minus x from both sides, all the x's go away. We end up with 4 is greater than 10. Well, 4 is not greater than 10. That's never going to be true. That's a false statement, right? So we call that a contradiction. Our answer is, when we see that untrue statement, 4 can't be bigger than 10, that answer is no solution. So sometimes that's going to happen where all the x's go away, and the answer is going to be all real numbers or no solution, and it works just like it was with the equal sign. If it's a true statement, is 4 less than 10? Yeah, it's always going to be less than 10, so all real numbers. If you end up with something like this that's false, then no solution. So let's try one of these right here. All right. So if you see a problem like this, first step most people would do is they would distribute, right? So we got 4y minus 4 is greater than or equal to, over here we have 4y plus 2. I can already tell the 4y's are going to cancel. When you minus 4y from both sides, we end up with negative 4 is greater than or equal to 2. Well, negative 4 is not greater than 2. So that is a no solution problem. Okay? If the sign was flipped, then it would be true. I can tell a problem like this. Yep, we're going to subtract x. Because we're subtracting, we're not going to flip that sign over. Over here I have negative 2. Over here I have a 1. Well, now negative 2 is less than 1. So yes, that's true. So that would be all real numbers. Okay, so again, if it's false, no solution. If it's true, all real. Okay, let's just try a couple more problems just to make sure we got it here. This one again, sure enough, yes, I would distribute. When I distribute there, I'd have 6 times 1 is 6. 6 minus x would be minus 6x. is less than 3x. I'd want to get all the x's on both sides. I personally would move to the left, even though, a lot of people would want to add that 6x over there. If you do that, you're going to have to flip it at the end. It's just as easy if you want to minus that 3x. We would not flip the sign here. That would be 0. We'd have 6. Negative 6 minus 3 would be negative 9. We would want to minus the 6. So we'd get negative 9x. We're not going to flip the sign here because we're subtracting. Now this step, when I divide by negative 9, yes, I'm dividing by a negative. Now I have to flip that sign over. Okay? Over here I'd have x. The negatives would cancel. 6 over 9 would reduce by 3 to 2 over 3. So your answer would be x is greater than 2 over 3. Another problem like this. Now, this one you could do it two ways. One, you could just deal with the decimals. We could, add the 0.2x. We could minus the 0.16x. But here's another trick. If you don't want to deal with the decimals, we can get rid of those. With all of these, if we move that decimal one time, that would be a lot easier to deal with. So what we can do, just multiply by 10. If you multiply both sides by 10, you'd get, basically you're just going to move that decimal over. We'd get negative 2x plus 0.9 times that. Move that decimal one time, that'd just be 9. Move that decimal over, it'd be 16. Now it just becomes a little bit easier to deal with. You don't have to worry about decimals if you don't want to. You don't have to do it this way. You can just start adding and subtracting from here. But a lot of people would like that trick. So, again, I personally would probably bring it to the left, but a lot of people here would, it doesn't really matter which way you want to do it. That's why I'm doing it some both ways. This one, 9, we're not going to flip the sign over here because we're just adding 2. 18, we would divide by the 18 to get the x by itself. 9 over 18 would reduce to a half. But notice, now we have the x on the right side. We don't like to leave our answer like that, so we'd want to flip that. And then because I'm flipping it, yes, we have to flip the sign. Okay? So, again, from here, it doesn't really matter if you add the 2x or if you minus the 16x, you'll get the same thing. If you do it this way, you just end up with the x on the right. You got to flip the sign. Okay? So other than that, try a few of these problems. Let me know if you guys have any questions, all right? Talk to you later.